Today we're going to be talking about Pythagorean theorem, and the first thing that we have are parts of a right triangle. So here we have a right triangle, and it's a right triangle because we have this 90-degree little symbol. Here the legs are the two sides touching the right angle. Okay, and so we also know those as the A and the B. So those two are the legs, right? Then we have the hypotenuse, which is on the opposite side of the right angle. And if we look here, we have here's the right angle, and then we have a little arrow pointing that way. That's opposite. So this side right here is going to be the hypotenuse, which is C. Okay. And the hypotenuse is always the longest side of the three sides. Okay, so let's put hypotenuse is always the longest. Okay. Let's look at the Pythagorean theorem. So in any right triangle, the sum of the squares of the shorter sides, which is A and B, will equal the square of the longest side, C. In other words, we have A squared plus B squared equals C squared, where A, B are the legs and C is the hypotenuse. Okay, so to visualize the theorem, the picture A squared, B squared, and C squared as actual squares with the side lengths that are equal to the side lengths of A and B. So here we have the areas of the two smaller squares, which is A squared plus B squared, will always equal the area of the largest square, which is C squared. Right, so here we have a square, and the area is 9 units squared, and then for the other one would be 16 units, right? So those would be A squared and B squared, and that's going to equal to 25. And so let's see if that's true. So first, originally in my triangle right here, we have 3 and 4 as our legs, so we're going to put 3 squared plus 4 squared, and then my hypotenuse is that 5, so that's why it's at the end where C squared should be. Okay, 3 squared is 9. And here we see on this side, the area of the square is 9 units, right? 4 squared is 16, and here the area of the square is 16, right? That's 4 and 4, 16. And then the hypotenuse would be 5 times 5, which is 25, or 5 squared, right? And if we add the two red squares, the 9 unit squared and the 16 unit squared, we should get 25. And we should get 25 because in the Pythagorean theorem, this says that it is a right triangle, and it is, and so this proves that it's a right triangle. Let's look at the Pythagorean theorem converse. And so let's say that the converse states that if A squared plus B squared equals C squared, then it is the right triangle, right? So for example number 1, we can say that can the lengths 16, 30, and 34 make a right triangle? Plug it into the theorem, and then we'll see if it does. Okay, so here we have 16 squared plus 30 squared equals 34 squared. We write it like that because the two smaller sides are A and B, right? And it doesn't matter which way you write it. And then 34 will always be the biggest, or C is always going to be the biggest side length. In this case, it's 34. Okay, so A squared plus B squared equals C squared, right? We plug those in, and then we try to see if are they going to match at the very end. So if we do 16 squared, we get 256. 30 squared is going to give us 900. And 34 squared is going to give us 1,156. Now let's add these two together and see if it gives me with that 1,156. So we got 256 plus 900. And I do, in fact, get that same number. So that means that the side lengths 16, 30, and 34 can be a right triangle. So it's a yes on this one. Okay. So for number 2, can the side lengths 12, 12, and 24 make a right triangle? Plug it into the theorem. Remember, we got A squared plus B squared equals C squared. C squared is always the biggest one. In this case, it's 24. Right? So we got 12 squared or 12 times 12, which is 144. So 144 on both. And then 24 squared, we got 576. Let's add 144 with 144, and we get 288. 288 is not the same as 576, so here it is not. Those three side lengths cannot make a right triangle because it did not pass the Pythagorean theorem formula. Okay. Let's look at the coordinate plane. It says the Pythagorean theorem can be used to find the diagonal distance between 2 points on the graph. We're going to create a right triangle where the diagonal is C, is the hypotenuse. Okay, it's kind of similar to you finding the slope and the distance here. So here we got 10 squared plus 7 squared. How did they get that? Well, they have this point right here, A, this point right here is B, and they want to know the distance between A and B. Okay, they got 10 by counting 10 units down, and 7 by counting 7 units to the left, or sorry, to the right, right? You could also have done 7 this way and 10 this way. The only thing is that we're talking about distance, so we're not going to use negative numbers here, okay? So if we use 10 and 7 for our A and B, we can find the distance, which is C, which is also the hypotenuse. Right, so we got 10 squared plus 7 squared. 10 squared is 100 squared, or sorry, just 100. 7 squared is 49, and C squared is just C squared. Right, we add 149, we get 149 is equal to C squared. To get rid of this square, we have to take the square root of 149, and once you get that, do you see how the square leaves the C? That's what it's supposed to do, okay? So the square root of 149 is going to give us 12.2. And once you put in the calculator, like the square root of 149, you don't have to put the square root anymore because you used it already, okay? So the distance from A to B, which is that side length C, is 12.2 units away.